Hi there, here we are, section 7.1. I wanted to look at question number 31 and 35 to show you how to work through these problems that are talking about the sampling distribution of x bar, because this is a strange concept. So the question reads, assume that the random variable x is normally distributed with a mean mu equals 10 and a standard deviation equal to 4, and we're going to let n equal 16. So this is the population. Variable x is normally distributed like this. And it says describe the sampling distribution of x bar for n equals 16. So here's our little paint picture. So we know, make sure my thing, let's do a fat one. This is the population, is normally distributed with a mean of 10, checking 10, and a standard deviation of 4. But the question is, if we take samples of size 16, what does x bar, what does the distribution of x bar look like? Well, x bar, here's our rules, here's how we use them. The mean of x bar is equal to the mean of the population, which is 10, and the standard deviation of x bar is equal to the standard deviation of the population divided by the square root of n. So in this case, that's 4 divided by, because the standard deviation of the population is 4, divided by the square root of 16. Wow, isn't that tidy math? 4 divided by 4 is 1. So, when this question says, describe the sampling distribution of x bar for n equals 16, the sort of answer that they're looking for is this. X bar is approximately normally distributed with a mean of 10 and a standard deviation of 1. And yes, you can just write this. You can simplify it and write it all mathy like that. So this is going to be a horrible picture, so just brace yourself for a terrible picture. But suppose this curve represents the population. So here we have a mean equal to 10, and the standard deviation is 4. Suppose this is the population. Right, this right here is x, the population, one guy. And this is plus 4, like that, so that was 14. And this is 6, because it's 10 minus 4. Sorry, that's a 10, in case you're having trouble reading that. So if we wanted to draw the x-bar curve onto this graph, you ready to, you prepared for my drawing skills? So it has the same mean, so x-bar has a mean of 10, so mu x-bar equals 10. And the standard deviation is now 1. So instead of hopping out 4, each one of these standard deviations is going to be much skinnier. So it's going to be more like this. The scary of drawing. Ooh. Like that. And that's sort of the standard deviation of x bar. Much skinnier. Okay, that's pretty lame. You can see why I stopped. Let's see if I can fill this in. You can see why I stopped drawing these pictures by hand. It's sort of acceptable. Yeah, I'll take it. I'm going to just walk away and take it, you guys. So this right here is more what x bar looks like. But to answer the problem, really you only need to write this. X bar is normally distributed with a mean of 10 and a standard deviation of 1. So, question number 35, find the value of x bar that is greater than 97.5% of all the values of x bar. It's a weirdly worded question. Give me a minute. I'm going to pause the video to clear my paint picture. The value of x bar that's greater than 97.5% of the other values. This is kind of a weird thing, and for me this is where the pictures come in handy, because without a good picture it's hard to draw. So we just decided, that x bar is normally distributed with a mean of 10 and a standard deviation of 1. So for the purposes of this picture, now this is x bar. So right there, this is the sampling distribution of all the different values of x bar that we could get. And now that mean is 10. We're going to hop out 1 standard deviation. I'm just putting a little scale on the picture for you. That's 1. We go out another 1, that's 12. Go back 1, that's 9. So what we want is some value. What is the value? We'll call it y, such that 97.5% of all the values are less than that. So I'm going to put it up here because it's going to be on the high end. I'm going to guess it's about here. So there's some value, question mark. Let's call the question mark y, because that's better algebra, such that the probability that the average will be less than this is 0.975. I just did a weird mathy thing, so let me go back to the problem. Find the values of x bar that is greater than 97.5 of all the other values. So this one here, if this whole probability, let's make it orange, or gross, that's kind of yellowy. So this whole percentage is 0.975. So that value there is bigger than 97.5% of the other values. Do you see what I did there? It's a little tricky. So we're essentially looking for, another way to say this, is the 97.5th percentile. 5th percentile. So you can do this on your calculator or on the z-table. Honestly, I recommend that you use your calculator. If you have one, it'll do it for you, and that's easy, so why not do it the easy way? You could do it the hard way. Why be that person? Okay, so I'm going to type up the instructions for how to find this on the calculator. Okay, so to find this on the calculator, what you do is you type, first of all, type second function vars, variables, that gives you the distribution, second function, the variable button, then you arrow down to this 3 inverse normal function, and then you hit enter. Forgot to type that. Enter. And then you type in the percentile that you're looking for. So in this case, everything to the left is 0.975. So type in 0.975, comma, then the mean, which is 10, and the standard deviation, which is 1. In this case, because we're using the standard deviation for x bar. And then you hit enter. And your calculator gives you 11.59. That's essentially 11.96. If you're doing this on the z-table, what you'll have to do is see this 975, you look inside the probabilities for 975. See, do you see it right there? 975. It's inside the probabilities. And then you go backwards to 1.9, and you go up 6. 1.96. So here, you say on a z curve, you like that z curve? 0. 1.96. This whole area is 0.975. So if you're doing it with the z-tables, what you do is you set 1.96 equal to, you essentially make a z-score. This number, what is it? Minus the mean, 10, divide by the standard deviation, 1, and you solve for that number, essentially finding the z-score backwards. So y equals 11.96. So either way, the answer to this question is 11.996. So that's saying if you have a value of 11.96, you are greater than 97.5% of all the other sample means you could have taken. It's a bit obscure, but it's important that you be able to at least solve these problems, and then you can soak up all the understanding as you go along. I know that's backwards, but there it is.